Okay, so we're going to do a leetcode problem today. It's an easy one. It's called flipping an image, which are given a binary matrix of zeros and ones that probably represent pixels. And to flip, and we want to flip it horizontally. And in order to do that, so each pixel, we just got to pretty much reverse the initial pixels. I think it's like red, green, blue, which does kind of make sense in a way. Um, but yeah, but they pretty much this algorithm asks you first you go through each pixel and you flip it. So instead of 110, it's going to be 011. And then to invert it, you just change zeros to 1. So yeah, as you can see, we want to flip this. So we want this to read, this pixel to read 011 as such, and then 010 is the same, and this is backwards, this is forwards, same with the last one. Yeah, so it's kind of just, it's really simply, it's done in 2 steps, so it's just a case of modularization. You first want to say, you first run through it, each pixel, you just say, hey, flip everything, and after that, just invert everything. So yeah, so here's a solution class. Here's the one, find and flip, invert image is our main one. But here are our helper modularized modular functions called we flip it and then we invert it. So yeah, pretty much as you can see, it takes the array or the binary matrix A, first we're going to flip it in place, then we're going to invert it in place. So we're not going to do any copying or anything. So it's going to be very space efficient. That was my first kind of approach to it. It was simple. So just to run through the functions, flip image, well, it takes the array, and you want to just iterate through an array. And how you do that is you just do for loops. So we're just going to loop through all the pixels, as you can see, all of them, which are pretty much the row and the row index. And then we just want to get the row length. This is a line 12. This is a variable that we use over, as you can see here, here, and here. So I just don't want to write length of that all the time. Then we're going to iterate through the column, but we're only going to go halfway through the column. So as you can see, if you want to flip something, like if you want 1100 to flip to 0011, all you got to do, so is you're flipping the first element with the last element, the second element with the second last element. So we only have to iterate through half the function. So we'll just iterate to this spot and then we're done. Right? So yeah, pretty much to do that you need a temporary variable. So the temporary variable is going to be the current number that we're on. And then what we want to do is set that current element that we're on, or pixel, or 0, 1 within a pixel. So we're working with ones and zeros. So we want to change this to the nth last one where we're at. So if row length is 5 and we're on the first one 0, the 0th length x minus 4, so that means we're grabbing the 4th, the last element in the array, and we'll put it to the first. Now we got to update the last to the temp, which temp is just the first. So this would just flip 1 with 0 because it's the first and first to last, and then second to last. So here, so you're flipping them, and that does it all in place. And the runtime of this is pretty much m times n, or the height times the width, even though we're doing half the height. So no, what did, yeah, I think it's 3. Yeah, no, actually it can be 4. So it's the runtime of this is equal to the width times the height times number of elements in each pixel. So it's nonetheless, because it could be, in this case, there's 3 pixels or 3 bits in each pixel, and this one there's 4. I don't have to say anything. Yeah, so at most it can be 20. So there can be 20 zeros and ones in each given point. So yeah, so that's how you flip it pretty much. I think it's just a shorthand. Never mind, I'm not going to say that. This is doing it in place. So once we have that, now we want to invert it. So we just, once again, we're going to, how you iterate through a binary matrix. Or a matrix is you go through the row index and column index. And we're going to change this in place as well, so we're not saving any auxiliary space. So each 0 bit as we go through it in the array, I mean not the array, but the matrix. If the matrix is 1, this is kind of a shorthand. This is like a ternary. This line 22 is, or this part is like a ternary in Python. So if that bit, that current bit is 1, we want to invert it. So then we'll set it to 0. Else we're just going to set it to 1 because that means it's 0. As you can see, so if we run this, Python, what's it called again? Flip image. Actually, it's this one. Line 51. No, I need to, that's my second solution. So, yep, so it's pretty much this case is what we're testing. So we want the output to look like this. So if you see it's 1 1 1 1 0 0 1 1 0 0 1 1 0 0 1 1 0. Yep, as you can see 0 0 1 1. It matches. We got it. Yeah, that's kind of like the modularized basic easy version of it, and it's just you just run these two methods in place, and so it's muting the original matrix. But there is a little redundancy. We iterate through the flip image once here, and then we're going to iterate through again. So we're kind of running through it twice, but I think you can do it once. So it's like in this step, when we flip it, if this equals to 1 or 0, then you just do the same ternary thing here. So you have to run through it once. But the thing is, but then you have to determine if the length of the array is odd or not, which is kind of weird. So that we can explain this. So if we it would look something like this. So if this part is to go on 1 or to flip it to 0. But the thing is, for an example, if we have like a 0, 0, 0, 1, 0, 0, what's going to do is it's going to iterate here to here, but it skips the middle one. So so all these would get flipped. This would turn 1, this would turn 1, this would turn 1, this would turn 1. But this wouldn't get changed since we don't iterate to that part of it in the initial, this divided by 2 part. So that means we'd have to throw in some logic to say, hey, if this length is odd, then you have to do the middle one too, the additional one, flip it. So also then this is all function would have to be. Instead of all of this you just be this initial iterating over it and flipping, and then you just integrate it. So I think it would be like, yeah, I think it would be something like if row length divided by 2 because we want to do modulo, if this equals, or what we're checking for is if it's odd, yeah. So if that equals 1, then we got to do initial check. What would that be then? Oh, I got a weird space. It would be would it be? It would be outside of it. Or no, if it's odd and the column index is equal to that rolled out length divided by 2, then we want to do an additional one. Yeah, well, I'm not going to do it now, but it'd be something like that, but it's kind of goofy, so. Unless, yeah, so if you use the original modularized version, if you accepted, so. Yeah, and then the runtime of this is, like I said before, the runtime is just your width times height times number of each element. So it's linear because well, if width and height, then it would be I think that's what it is. Yeah, there would be what's the word? Exponential. So, because this is pretty much a constant, because this is 20, guaranteed 20. So, yep.